Here we have a marketing company has determined the demand function for wireless headphones is P equals negative 0.085x plus 900, where P denotes the headphone's unit price in dollars and X is the quantity demanded. You'll notice that up here there is between 0 and 30,000. We don't really do much with that right now. That just says they're creating between 0 and 30,000 headphones per day. They can't make more than that. So we'll only need to pay attention to the 0 to 30,000 if we're trying to tell them to create 35,000 to maximize the revenue. Obviously, that's not realistic. So we're just going to stay within that range, but otherwise we won't use it too much. The first part says find the revenue function. So I'm going to use the formula from before. R of X is X times P. So X times P here is given to be negative 0.085 X plus 900. So replacing that P from above into our formula. Revenue is X times P, and now we need to distribute this X to both terms. So X times negative 0.085X is going to be negative 0.085X squared. And then distributing the X to the positive 900 is going to make it positive 900X. So there's our revenue function. The next part says find the marginal revenue. So the formula for revenue is X times P, and marginal always means take the derivative. So there's no formula here. We just need to take the derivative of R, because the derivative of revenue will be marginal revenue. So we're going to take the derivative by bringing down our power. Negative 0.085 times our power is 2 is going to give us negative 0.17. And then we'll have X to the first, or just an X. And then the derivative of 900X will be 900. So there's our marginal revenue. Part C says determine the number of headphones demanded to produce the maximum revenue. So we need to remember from 4.1, maximum of anything, to find max or min, means first take the derivative and then make a sign chart. So I'm going to take the derivative. To maximize anything, we take its derivative and set it equal to 0. Well, I already took this derivative above. If I want to maximize revenue, I take marginal revenue, take R prime, which was negative 0.17x, plus 900. I'm going to take the derivative and set it equal to 0. So we need to solve this. This one I don't even need to factor. It's not as hard as the 4.1 problems. We just need to move that 900 over. So I have negative 0.17x, and I need to subtract 900. To move the plus 900 over, we'll subtract it. And then the next thing I need to do to get x by itself is divide both sides by negative 0.17. So my x value, my critical number here, is going to be negative 900 divided by negative 0.17. That's about 5,294, and it's an x value, so I have to figure out what I'm measuring. Well, for this one, x is measuring headphones. And that is perfect because that's between the range that I was given. They can make between 0 and 30,000 headphones, as we saw above. And hey, we're only saying to make 5,294 headphones. But like within 4.1, a critical number can be a relative maximum or a relative minimum. I don't want to accidentally minimize their profit, so I'm going to make a sign chart as my second step and make sure that that really is going to maximize revenue and not minimize it for some reason. So I'm going to put my critical number here, 5,294. I'm going to point to it. This is something special. This is what makes the derivative 0. So R prime of X is 0 here. And I want to figure out what is happening with my derivative before and after. So I can plug in anything before 5,294. Maybe I could plug in 5,000. I'm going to do something easy so I can do it in my head. I'm just going to plug in 1 or maybe even 0. Here I'll just plug in 1 into the derivative always on a sign chart. So negative 0.17 times 1 is just going to be negative 0.17 plus 900. I'm definitely going to have a positive number. So we have a positive derivative, which means before our critical number, we're increasing. If I plug in anything after here, maybe I'll plug in 6,000. Here I might actually need a calculator. I'm going to do into the derivative, negative 0.17 times 6,000. Well, I get negative 1020 plus 900. Well, 900 take away 1020 is going to give me a negative number. So I went from having a positive derivative to a negative derivative, which is perfect because positive to negative means I really did have a maximum there. So they really should have made this 5,294 headphones in order to maximize their revenue. So again, anytime you see maximum, you're going to take the derivative, set it equal to 0, and make a sign chart. So maximizing revenue, we use the derivative of it. But of course, the next question the company is going to ask is not just tell me how many I should make. They want to know how much money they're actually going to make from it. So the next part says, what is the maximum revenue? So we determined the number of headphones should be 5,294 headphones, and they want to know how much money they're going to make. So to figure that out, I'm just going to plug into revenue. What is the revenue when we have X is 5,294? So if we plug in, we're plugging into the original. So we're going to do negative 0.085, and we're going to do 5,294 squared. And remember PEMDAS, you have to square this before you multiply. So if you have a graphing calculator, you can plug in just like this. If not, you have to square always before you multiply. And I'm just replacing both x's from the revenue equation above with what x is, 5,294. So in a calculator, you want to square it, multiply it by negative 0.085, and then add 900 times 5,294. And what you should be getting is a pretty big number here. We have $2,382,352. It doesn't tell me where to round to on this because we're talking about money, so you want to round to the nearest cent always. And that's 94 cents on there. So there is my maximum revenue that they're going to make off those 5,294 headphones being sold. $2,382,000. $2,382,352.94. Not a bad revenue.